Okay, let's look at this. X minus 1 when x is greater than 0, minus half when x is equal to 0, x plus 1 when x is less than 0. So again, we need to look at the left-hand limit. So here there are three separate functions depending upon the range of value. Now f of 0 is nothing but minus half as told when x is 0. When x is less than 0, so this will indicate the left-hand limit. Left-hand limit is going to be when x plus 1. So it's going to be 0 plus 1, which is 1. So that means definitely the function and the left-hand limit are not equal. There is no need to further do it. Definitely it is discontinuous at x is equal to 0. Because if you take right-hand limit, it is going to be 0, minus 1, minus 1. All three are different. So definitely it's going to be discontinuous at x is equal to 0. Okay, this is definitely heating up. Furthermore, we have a situation. F of x is equal to x squared minus 1 divided by x cubed minus 1 is undefined at x is equal to 1. The value of f of x at x is equal to 1 such that it is continuous at x is equal to 1 is. Okay, to make it continuous at x is equal to 1, what do we have to do? We have x squared minus 1 divided by x cubed minus 1. So we are going to write it as x minus 1 into x plus 1 upon x minus 1 into x squared plus x plus 1. So this gets cancelled. So f of x becomes this. But we want it to become continuous at when x is equal to 1. To make it continuous, we need to find out f of 1 itself. Now, at this stage, so you get 1 plus 1 upon 1 square plus 1 plus 1. You say that the function is continuous at x is equal to 1, which means you need to factorize and make the function a determinate function, and then for that particular value of x, find the value of f of x, which is going to be 2 by 3. So the value of the function f of x will be 2 by 3 when x is equal to 1, so that it becomes continuous at x is equal to 1. So f of 1 is going to be 2 by 3. So which is going to be option number B. Okay, we have it right. Further, f of x is 2x minus absolute value of x is undefined at x is equal to 0, discontinuous at x is equal to 0, continuous at x is equal to 0. So let's see. Now let us see what is f of 0. F of 0 is going to be 2 into 0 minus absolute value of 0, which will be 0. Now let's see what is limit of f of x, left-hand limit, as x approaches 0 from 0 minus h. So this will give you 2 into 0 minus h minus 0 minus h, which will be minus 2h plus h, which is minus h. And I told you we need to check whether this function is going to be continuous. So for that we have to keep h as small as possible. So that means you have to keep h's value 0, and hence it turns out to be 0. So you find that f of 0 and left hand limit are equal. Now let's see what the right hand limit is. Limit of f of x as x approaches 0 plus, that is, substitute x as 0 plus h. We get 2 into 0 plus h minus 0 plus h. So this turns out to be 2h minus h, which is h. And again, h has to be made to make the limiting, find the limit value of this f of x. We substitute as s. So we find h as 0. So we get left hand limit, right hand limit are equal. And also f of 0 is the same. That means the function is continuous at x is equal to 0. Yes, we do have it. Okay. Here we have an interesting example. If f of x is 3 whenever x is less than 2, f of x is kx square when x is greater than or equal to 2 is continuous at x is equal to 2, which means that left hand limit is equal to right hand limit is equal to f of 2. Now both these are one and the same because the function is defined by kx square whenever value of x is greater than or equal to 2. So this is going to be k into 2 square. And the left hand limit is equal to, when x is less than 3, it is equal to 3. So 3 will be equal to 4k. So k would be equal to 3 by 4. So the value of k would be 3 by 4, so that the function is continuous at x is equal to 2. Okay. So we have x square minus 3x plus 2 upon x minus 1 becomes continuous. Now we need to factorize it. This one factorizing gives you x minus 2 into x minus 1 upon x minus 1. So this x square x minus 2 into x minus 1. So we have this. That means f of x turns out to be x minus 2. That means the function is continuous at x is equal to 1 means f of 1 will exist. So in that case it is going to be 1 minus 2, which is minus 1. So f of 1 is going to be 1 minus 2 by minus 1 because the function is continuous at x is equal to 1, and hence the value of f of 1 would be minus 1. Okay. Alright. We have it tallying with whatever we got. Okay. Now here f of x is equal to x square minus 2x minus 3 divided by x plus 1 whenever x is equal to not equal to 1, and f of x is equal to k when x is equal to minus 1. If f of x is continuous at x is equal to minus 1. So it's going to be one function is x square minus 2x minus 3 upon x plus 1. This can be written as x square minus 3x plus x minus 3 upon x plus 1, which turns out to be x minus 3 into x plus 1 upon x plus 1. So that means f of minus 1 is going to be 1 minus. Told that this function is valid for all values of x except when x is equal to 1. So now f x is equal to minus 1, this function is bound to be valid. So f of minus 1 is 1 minus 3, which is going to be minus 1 minus 3. I'm sorry, minus 1 minus 3, because when f of minus 1 will turn out to be minus 4. But it is also told that f of x is also k is also equal to f of minus 1. That means k will be equal. If you say that the function is continuous at minus 4, you consider this as a function or you consider this as a function. Both ways it is continuous. Both the values of the functions have to be the same. So it's f of x, f of minus 1, both of them will be equal. So the k's value turns out to be minus 4 among these. Okay, we have it that way. Okay, now you have one more example. Let f of x be equal to x when x is greater than 0, 0 when x is equal to 0, minus x when x is less than 0. Now f of x is what? Now we have done this example earlier. So the right hand limit as per this is going to be 0. As per this, f of 0 is also 0. As per this, left hand limit is going to be minus of 0, which is 0. So all three are equal. So definitely continuous at x is equal to 0. So the total cost C of purchasing of a certain commodity is given as so and so. So you have to check whether at x is equal to 500 the function C is continuous, discontinuous, or both of them. So at x is equal to 500, hence we are going to look at these two clauses because we are looking at continuity. So f of x, so when you're considering f of x and left hand limit, it's going to be the same. That means it's going to be f of x when x moves towards 500 negative, that is from lower values of 500, you end up getting is equal to f of 502, which is going to be 100 plus 2 into 500, which is 1100. So the left hand limit and f of x is 1100. Now let us check for 500 plus 500, that is for x greater than 500. So it's going to be right hand limit is going to be 500 plus x, that is 500 plus 500, which is 1000. So you get 1000. So we see that the left hand limit and right hand limits are not equal. So if they're not equal, obviously at x is equal to 500, the function is definitely discontinuous. So at a practical level, there is some lack of definition regarding this particular value. That's the reason why you're getting a discontinuity. So at x is equal to 500, it is definitely discontinuous. All right. Okay, so what do we have here? We have f of x is x square minus 1 upon x minus 1 for x is not equal to 1, and f of x is equal to 2 for x is equal to 1. Then the function f of x at x is equal to 1. So we need to assess for this. Now f of 1 in any case is 2. This is something which is stored already, so keep that aside. Now let's take the left hand limit. Left hand limit is obtained by limit of f of x as x approaches 1 from 0 minus h. So what we do is we take it as 1 minus h, is equal to 1 minus h the whole square minus 1 divided by 1 minus h minus 1, which will turn out to be 1 square minus 2h plus h square minus 1 upon minus h. So this gets cancelled. We can take out minus h common, and you get 2 minus h upon minus h, which turns out to be 2 minus h. Now we know that we are coming closer and closer to 1. So we keep h. To find the limiting value of this, we need to take h as 1. So this is as 0, So it's going to be 2 minus 0, which is 2. So the left hand limit is also 2. Then let's check the right hand limit. Limit of f of x, this is minus, as x approaches 1 plus, is going to be 1 plus h the whole square minus 1 upon 1 plus h minus 1. This will turn out to be 1 plus 2h plus h square minus 1 upon h. This gets cancelled. So you get h into 2 plus h upon h. This gets cancelled. So ultimately it's 2 plus h. So the limit is obtained by taking h as 0, 2 plus 0, which is 2. So the right hand limit also turns out to be 2. So left hand limit is 2, right hand limit is 2, f of 1 is 2. So definitely the function is continuous at x is equal to 1. Okay, so let's check whether what we have in the offering is tallying with what we have got. Yes, it is continuous at x is equal to 1. Okay, let's take this. Let a function be defined as 4x when x is greater than 0, less than 1, 5 minus x when x is greater than or equal to 1. Right, so left hand limit is going to be limit of f of x as x approaches 1 minus, we are going to check for 1. So it's going to be, we are going to consider this function, so it's going to be 4 into 1, which is 4. And f of 1 is going to be 5 minus x, that is 5 minus 1, 4. And right hand limit is going to be limit of f of x as x approaches 1 plus is also going to be, you can even substitute x as 1 plus h, which is also the same. So you get 5 minus 1, which is 4. So all the three are equal. So definitely the function is continuous at x is equal to 1. For x is equal to 0, we don't know, because there is only, we don't know what the value of the function is when x is less than 0. So hence it cannot be continuous at x is equal to 0. Continuous nowhere is wrong. It's definitely continuous at x is equal to 1. Yes, right? It tallies with what we've got. Okay. Now we have 5 minus x squared by 5 when x is greater than 0, less than 5. 0 if x is equal to 5. 5 minus 5 cubed by x squared if x is greater than 5. So we are looking at the function's continuity at 5. F of 5 is equal to 0 as per this. Left hand limit is going to be obtained by considering this. It's going to be f of x, limit of f of x as x approaches 5 from negative value is going to be 5 minus 5 squared by 5, which is 5 minus 25 by 5, 5 minus 5, 0. So left hand limit is also 0. Now let's check right hand limit. We have limit of f of x as x approaches 5 plus, hence we consider this 5 minus 5 cube upon x square, that is 5 square, which is going to be 5 minus 125 by 25, which is 5 minus 5, which is 0. So left hand limit, right hand limit and f of 5, all three are equal. So it is continuous at x is equal to 5. Let's check. Yes, we do have it that way. Okay. Now, fine. It's told that f of x is x squared plus k into 1 minus x minus 2x divided by x minus 2 if x is not 2, and f of x is 2 if x is equal to 2. Continuous at x is equal to 2, which means that f of 2 is going to be equal to left hand limit and right hand limit, which means that this function is valid for both left hand limit and right hand limit, which means that x squared plus k into 1 minus x minus 2x upon x minus 2 would be equal to f of 2. Is what it's told whenever x is 2, which means that f of 2 is 2. So 2 into x minus 2 is x squared plus k into 1 minus x minus 2x. It is told that it is continuous at x is equal to 2, so we don't substitute 2x as 2 here. After cross multiplying we do it, so you get 2 into 2 minus 2 is equal to 2 squared plus k into 1 minus 2 minus 2 into 2. So this turns out to be 2 into 0 plus 4 minus k minus 4. So this gets cancelled and you get minus k is equal to 0, which means that k is equal to 0. So the value of k will be 0 if the function is continuous at x is equal to 2. The function is continuous, it means that such a function exists, hence further mathematical computations are admissible or acceptable to us. Hence we are getting k is equal to 0, right? Okay. The function y is equal to x is discontinuous at x is equal to 0, discontinuous everywhere, continuous everywhere. So y is equal to x. Let's check any value you take. So we can take any value. So x minus h, for example. So if it is y is equal to x, means it is going to be continuous or no. So any value less than x, it's going to be y. Suppose you take x is minus x. We know that x is going to be, absolute value of x is going to be x itself if x is positive, and absolute value of x will be minus x if x is negative, and it is going to be 0 if x is 0. So any one of these values you consider, you will find that if you take the negative, so you take absolute value of x, in this case we take it as absolute value of x, it is going to remain continuous in any case. Continuous, it will be x continuous everywhere. So if you take, for example, x as any value, say 5, absolute value of 5. So if you take absolute value of 5 minus h, if it's positive, is going to be just 5 minus h. You can take it as h as 0 and you get 5. So any value of h, you take it absolute value of 5, and suppose you take absolute value of 5 minus h as positive, so it's going to be in that case, accordingly you will change it to 5. So it's going to be continuous at any possible place, anywhere you take the value of, you are taking h as 0 here, at any value of x, it's going to be a continuous function. It's going to be a continuous value for all values of x. It's going to be continuous. That is the left hand limit as well as the right hand limit as well as the value of the function is going to remain continuous here. Okay, so it's continuous everywhere. Okay, we have one more concept here. Function f of x is equal to k into x minus 1 for x less than 2, x minus k for x greater than 2, and it is continuous at x is equal to 2. The value of k is what? So again here, left hand limit, right hand limit, and f of 2 are equal. So left hand limit, for that we consider this. So it's going to be k into 2 minus 1. Right hand limit and f of 2 are the same, which is going to be x, that is 2 minus k. Wherever there is x, you put in 2, and hence you get 2k minus 1 is 2 minus k. So 3k is equal to 3. So k will turn out to be 1. Hence k is 1. Okay.